Okay, hi student. Uh, Anybody can answer me. You can listen or cannot listen. Then you can see me or not. So we make sure you can see. Then we start the lesson. Okay. So, student, can you answer me? Okay, we just chat inside the chat room. So I can see your chat room. Then you can see me. You can listen me. Okay, can okay, Sarah, you can see me. Okay, morning, Si Liang. Okay, so today we want to continue our lesson. There's a chapter 2. Okay, how about you all after the Chinese New Year holiday? Okay, so we continue our lesson again. So from here, we need to go, okay, today topic, we go to lesson 2.1. Okay, 2.1, there's a linear motion. So we're talking about the calculation. Normally for this topic lah, that's for calculation. Okay, let's see what is a linear motion. Okay, first one, linear motion, there's a motion in a straight line. Okay, when you see the motion in a straight line, that means the object is moving in a straight line. We call it as a linear motion. So that means this one you can say about the definition for linear motion. Okay, motion in a straight line. Okay, number two, can see the diagram. Okay, the car is moving in a straight line, is it? So we can say now the car is linear motion. Okay, next. Okay, from here, linear motion, we can be described to the different terms. Okay, we got distance, we got displacement, we got speed, we got velocity, and also the acceleration. I think this one you learned before from the chapter 1, there's a physical quantities. Okay, so from here, we need to learn one by one and also need to differentiate what's the distance, what's the displacement, what's the difference. Okay, speed and also velocity, we also need to find what is the difference. And the last one should be the acceleration. Okay, let's see one of the diagram here. Okay, you can see distance and displacement. What's the difference? Okay, distance is a blue color line. Displacement is a red color line. So you can see this one is what's different for the distance and displacement. Distance is always is longest one. Okay, they move anyway, we also need to plus the one we call distance. Okay, displacement, you can share there's a shortcut. Okay, from the starting point, straight line go to ending point, that one we call displacement. Okay, so we continue, this one just diagram only, then you can see more detail about the following physical quantities. Okay, now we go to first one. There's a distance. Before we learn about the distance, we need to know definition. Okay, for the physics, every time the physical quantity, we need to know about the definition. We need to know about the formula. Then we need about the characteristic. Okay, let's see the first one. Okay, distance, the definition is a total path travel from one location to another location. So that means we don't care about direction. Where they just go with plus all together, that one we call distance. Okay. Then the next one is the magnitude is depends on the road covered by the object. So we don't care where you go. When you just plus together all the magnitude, that one we call distance. Okay, and the last one is distance is a scalar quantities. There's a no direction, and the SI unit for the distance there is a meter. Okay, so we never using cm, we never using the millimeter. If the question just mentioned SI unit, understood, we using meter. Okay, unless the question never mentioned, then you're using cm, you're using millimeter, is okay, but make sure your changes decimal point must be correct. Okay, now you see the example here. They got distance. Okay, from A, the car is moving. Okay, go to the B. Okay, for 100 meter. After that, from the B, they turn back. Turn back, go to C, is 40 meter. Okay, if the question asks, what is the distance? So you just 100 plus 40, there's 140 meter. Okay, so this one we call distance. Okay, got any problem? I think no, is it? Distance just a simple things only. Okay, then we go to the next one. Okay, the next one also is the same meaning, same like the distance, but this one got direction. So this one we call displacement. Okay, these two just like brother only. Okay, two brothers. Okay, one got direction, one is no direction. Okay, now we're going to see the displacement. Okay, displacement means the shortest distance between the final point and also the initial point in the specific direction. So that means displacement, we need to count from the first point to the final, that's all. Then we draw one straight line, that one we call displacement. Actually, there's a one of the shortcut lah. You can say about a shortcut. Okay, then the next one. Okay, its magnitude is a straight line distance between the initial position and also the final position. So they're just straight line. So you draw one straight line from the initial to the final. So that one we call displacement. Okay, and the last one. Physical quantity, there's a vector. So that means if they go to right and go to the left, that means you need to take one become the negative direction. So the SI unit is still the same, that's a meter. Okay, let's see the example diagram here. Okay, A go to B is the same. There's a still 100 meter. But from the B, go to the C, there's a 40 meter. Okay, so if the question asks, what is the displacement? Sorry, this one not distance, displacement. Okay, what's the displacement? So your answer is, you take 100 positive, go to the right, then you need to plus what? Plus 40 but negative. Okay, you need to assume go to left hand side is a negative direction. So that means you take 100 minus 40 lah. So this one is the starting point A, ending point is a C. So you just count from A go to C, that's all. That one is a displacement. So from here I get 60 meter. Okay, don't forget you need to measure about direction, where they go. A to C only. So that means there's a go to the east. Okay, this one is a direction. This one is a east. Then after that we got west. Then we got south. Then we got west. Okay, then we got north. So when they go to right hand side is the east. So there's a 60 meter to the east from the direction A. So you need to mention where the object to go. Okay, so this one is a displacement. Okay, so this one correction, not distance, that's a displacement. Distance, you no need to mention about the direction one. Okay, so hopefully you understand what's the different distance and also displacement. Okay, now we go to another things. Okay, uniform velocity and non-uniform velocity. Okay, uniform, everybody understood. Uniform means constant. Okay, that means your velocity always the same. Okay, non-uniform means your velocity will be changes. Okay, now we go here. Okay, assume the right direction as a positive direction. Okay, normally we assume like this, like the right hand side is a positive. Okay, now we're going to see the diagram. Okay, now the car start from the 0 second. Go to move. Move until 3 seconds. Okay, can you see the distance almost the same? 20, 20, and 20. So that means every 1 second, the car will move 20 meter. Okay, so from here we can say the car is moving uniform velocity because the rate of change of displacement remain the same. Okay, you need to see the keyword I highlight already. There's a blue color, rate of change of displacement. So that means every displacement for changes with the time, there will be uniform. So I can say this blue word, I go to highlight, there's a meaning of velocity. Okay, rate of. When you see the word rate of means the formula must over the time. Okay, then over time, which one is over time? Changes of displacement. Displacement over time. So that means there is a velocity. So now if you want to count the velocity, that means you just take 20 meter over 1 second. So there's a 20 lah. So that means every time the car just moving 20 meter per second velocity. So we can say this one called uniform velocity. You also can say rate of change or displacement, same. Okay, that's the same meaning. Just this one is a definition. If you don't want to mention definition, you just mention there's a velocity. Okay, now I need to show it's non-uniform velocity. Okay, non-uniform velocity. So you can see the car is keep increasing distance. Okay, the time taken is the same. When starting, I move 1 second in 20 meter. Okay, another 1 second, I already go to 30 meter. Means the car now is faster already. Okay, faster means the velocity cannot become constant. Okay, when you do the calculation, 20 over 1, 30 over 1, then different already. So 20 become 30. So that means the car now is faster, accelerate. So from here, we say the car is moving at non-uniform. Okay, velocity, because the rate of change or displacement is increasing. Okay, because the velocity now is increasing. So we can say there's a non-uniform velocity. Okay, so from here, make sure you know what means a uniform, what means a non-uniform. Okay, now we continue for velocity decreases. Okay, what means a velocity decreases? Okay, this one. So that means I start from the 0 second, I move 30 meter in 1 second, but later I move 20 meter in 1 second. That means the car now is slowed down already, is it? So slow down the car acceleration. Okay, now the car is acceleration, but in opposite direction. Then you can say slow down. You also can say the car now is accelerate. How to accelerate? Opposite direction. Opposite direction means that slow down already. They go to left hand side already. That means we never say the car is totally go to left hand side. We just say now you slow down. That means you never pick up. So we can say you are acceleration in opposite direction. So you can say there's a deceleration for the car now. Okay, so if the question they ask how about the acceleration, then you must mention the acceleration is opposite direction, mean we can say negative acceleration. Okay, negative acceleration, then you understood there's a slowdown. Okay, so this one is a velocity decreases. Okay, then we introduce another type for the linear motion. There's a speed. Okay, speed definition. Okay, rate of change of distance. Okay, can you see distance? Okay, distance is a scalar. So speed sure is a scalar lah. Rate of. So rate of understood must over the time. Okay, change of distance. So distance is put above lah. Then the time taken is below. So that means the formula is a distance travel over the time taken. So this one is a speed. So the formula V equal distance over T. T is a time taken. Okay, now we go. Okay, quantities, there's a scalar. They follow the distance, so the no direction. Then the SI unit is meter per second. Okay, now we got one of the example question. So the student, you are ready to type your answer here. Okay, so from here, you prepare your calculator. So we straightforward to answer this question. Okay, an object that move along the path A to B. Okay, I show the diagram first. Okay, they move along the path A to B. Okay, A to B is go up. Okay, after that, from the B, they go to the C in 20 seconds. So give that the AB is a 6 meter, BC is a 8 meter, then the AC is a 10 meter. What is the speed? Okay, so you can start to show me, no need to show lah, just give me the answer. I want to find speed. Okay, so that means the object just moving from A, B, then C, then finish. Okay, anybody just on the live stream, you can type your answer here. What is the speed? Okay, we check any student can answer it or not. Okay, still not yet. We got some student already here. I find it. Okay, we got Swen, we got Aina, Theo, Sarah, Lim Si Liang. Okay, Si Liang give me 0.7 meter per second. Okay, so suppose we're using the speed, is it? When I just mentioned about the speed, that means we're using distance. So Siliang, you tell me the distance you're using 10 meter or 6 plus 8. Okay, Yanzi also answers 0.7 already. So I think the student also understood. When I just mentioned the speed, that means you must say rate of change of distance, is it? So we're using the distance, don't using displacement. So from here, okay, Siliang, correct? Okay, Siliang, they told me they're using the distance. Okay, 6 plus 8. Okay, so from here, we're going to see the answer, exactly answer from the, okay, Celia, give me the full answer if you need. Okay, so velocity equal displace distance over the time. So from here, we're going to show distance over the time. So that means we're using 6 plus 8. Okay, 6 plus 8, after that over the total time taken. So the total time taken is 20 seconds. So we find it 0.7 meter per second. Okay, correct for the student. Okay, alpha is also correct using 6 plus 8. Okay, so now we go to the next question. Okay, next question. There's a sibling with the speed also, but the name we call velocity. Okay, this one velocity, they also rate off, but now we got direction, so we cannot using distance. So from here, okay, city, you also correct as 0.7. Don't forget to write the unit. Okay, so the velocity is a rate of change of the displacement. Okay, now displacement over the time. So you must be careful. Now it's displacement. That means got direction already. So you need to take the shortcut. Okay, the formula is the same. V equal displacement we're using S, S over the T. Okay, now, okay, vector quantities. Okay, there is a vector quantities, and also the SI unit is the same. There's a MS negative 1. Okay, now we're going to see the same question. Okay, the question is the same, but now they ask about velocity. So you can find out which one should be the answer. Okay, we're still using 6 plus 8, or we straightforward using 10 meter. Okay, so you also can press your calculator, then you show me the answer here. Okay, so we're going to see which one is the fastest one. Okay, so the velocity, we apply the same formula lah, displacement over the time taken. Okay, okay, so we get it, Karen. Karen, show me the answer is 0.5. Okay, meter per second. Shania also same. Okay, I think the answer should be the correct lah. Most of the student also can get it. Okay, Jolene also same. Okay, now we're going to show the calculation. Okay, many students also give me the same answer. Okay, now we go and check it. Okay, velocity equal displacement over the time. Okay, so now we go and see it. 10 over 20. So the answer is 0.5 meter per second. Okay, correct for the student. Wei Xuan also correct. Okay, remember, don't forget the unit. Okay, you can put meter, put slash second. You also can put ms, then up you put negative 1. Okay, that's the same meaning. Okay, so now we go to the next. Okay, the last one, the physical quantity we need to know for linear motion, there's a acceleration. Acceleration means now the object is moving fast and fast. Okay, so from here we need to know definition first. Okay, acceleration means rate of. Can you see the word rate of means still over the time? Okay, what is over the time? Change of velocity. Okay, they got one word, change of velocity, means we need to using the final minus the inertia. So we call change of velocity. Okay, so from here we got final velocity minus the initial velocity, then over the time taken. Okay, so from here the formula should be A equal V minus U. V is a final. So we need to know at the final the car is moving how fast. Then minus initial. Okay, when starting the car is how slow. Okay, after minus, then you divide by the time taken. Then you find the acceleration. If you find the acceleration is a negative, means what? Means the car is slow down lah, or you can say acceleration in opposite direction. Okay, if you find the acceleration is a positive, means the car is faster and faster, velocity increasing. Okay, now we're going to see the vector quantities. Acceleration is a vector quantities. Okay, because this one using the velocity over the time, so we need to s square already. Okay, you just now already ms negative 1, is it? Now you per time again, so become ms negative 2. So this one is a acceleration. Okay, now we go through the question. Okay, let's see the example question here. Okay, diagram they show about the boy. There's a running through the 3 points P, Q, R. Okay, with the velocity 4, 3, 2 respectively. The boy is running with, okay, so we need to answer lah. From here, the boy is running, no calculation, I just answer the motion only. What is the motion of the boy? Okay, motion, that means you just can answer velocity, you just can answer acceleration. Okay, either you say velocity increase, either you say uniform velocity, or you just say acceleration also can. So anybody can answer me this question. The boy is running with, okay, what motion? Can you see 4 become 3 become 2? So your answer can be answered as, how about the velocity now? Okay, just tap here. Okay, become slow, is it? But we cannot answer slow. Slow is not motion. Fast also not slow motion. So you just can answer either velocity, either acceleration. Okay, deceleration. Okay, the others? Got other comments or not? Okay, you also can give others if you think that one is not answer from Celia. You can give me others one. Depends. Acceleration in opposite direction. Yeah, correct. Okay, velocity decreases. Also correct. Okay, so 3 answer here also correct. You see, Celia give me the answer deceleration. Okay, then Chanel give me the answer is a acceleration in opposite direction. Okay, after that, Gu Hong Nian give me the answer is a velocity decreases. Okay, suppose it's the same meanings. Okay, another answer from the Zhong Yanze give me non-uniform velocity. Non-uniform velocity, I think that's a not accurate answer because they say non-uniform velocity, but we need to specific. I know there's a non, but you need to more detail, fast or slow. Okay, so Yanzi don't give the common meanings. Okay, you can say velocity decreases, don't say non-uniform. Okay, so from here we go and see the answer. Uniform deceleration. Okay, you can put deceleration also can, uniform also can, because I find it the 4 become 3 then become 1 every time, they just less become 1, so we can put uniform deceleration. Okay, so from here this one should be the answer. Okay, because so many answer different, although the meaning should be the same. Okay, then we go to the next part. Okay, example 1. Okay, let's see the figure. They show the Razis, the run from A, then to the B, then back to the C. Okay, first one, the total time taken is 20 seconds. Okay, determine the distance. Okay, tell me what is the distance. Okay, what's the distance from this question? Okay, distance, very fast only distance. You just tap here. Distance. Okay, Paris, that's distance. Why you suddenly show me the velocity? Okay, distance is a 120. So from here, Jolene answer already. Okay, so from here, we show the answer distance. That means we don't care about direction. We just plus only. So from here, the answer is a 120 meter. Remember the meter. Okay, so this one is the answer. Okay, next, the question sure we ask about displacement. Okay, displacement is, okay, the student must ready. Answer A give ready. The answer B, you must straightforward to type it. Okay, the displacement is, okay, we just waiting. Okay, Deepika Mohan also correct. Sarini, okay. Then we continue to the second question. Displacement for the Razis motion. Okay, displacement. Then you need to take the right hand side is a positive. Okay. Answer me already, all the student. Give the same answer. Wei Xuan, they give me 80 meter. Okay, we need to show calculation. Okay, displacement equal 100. Okay, after that, plus, then you need to put bracket negative 20. So mean this one is the opposite direction. Then the final answer is a 80 meter. Many of you never mentioned about the direction. So direction is go to the right. Okay, 80 meter is from the A go to the C. So there's a 80 meter to the right. Okay, you need to mention about the direction for the displacement. Okay, then we go to the next question. Okay, also example one, they ask about the speed. Okay, what is the speed? So you can answer here. Okay, speed. Speed means using the distance over the time taken. Okay, we call it speed. Okay, speed. Okay, time taken is 20 seconds. Okay, speed. So anybody can answer me? Okay, Xiliang show me there's a 6 ms negative 1. Okay, we're going to show. Speed is 120. We take the distance now over 20. So we find it there's a 6 ms negative 1. Okay, so the student answer correct. Selene, Krishna, there's a 6 meter per second. Okay, the next question sure is a velocity. So velocity, student, ready to press the calculator to tell me what is a velocity. Okay, the velocity, that means we cannot using the 120 already lah. Okay, velocity got direction. So you need to find out displacement. Take the displacement over the time taken. Okay, so okay. Jia En give me the answer already. There's a 4 ms negative 1. Okay, so we go to check. Okay, velocity, there's a 80 over 20. So there's a 4 ms negative 1. Go where? Go to the right. Okay, so mention about the direction. They go to the right. Okay, so this one is a velocity. So that means the student understood already lah. Distance, displacement, speed, and also the velocity. Okay, then we go to the next. Okay, now Mutu, they move from O to B. O to B, along the OAB. Okay, if they move long, that means O to A, then A to B. They show in the figure. So the time taken is 15 seconds. So can you determine the distance? Okay, can you determine the distance? Okay, the distance is, okay, what is the distance? Okay, distance, we just see the diagram, then we understood already, is it? So the distance is no direction, and also there's a long way. So 17, okay. Deepika, they give me 17. So we just show distance is a 5 plus 12, so become 17 meter. Okay, meter, must put the meter. Okay, then we continue with the displacement. Displacement, I no need to show already because diagram got already. But if the diagram never give 13 meter, how you go to find the displacement? So from here, they show for you. Okay, displacement means the shortest straight line distance from the O to B. Okay, this one we call displacement. Okay, how to find out if the question never provided? Okay, we're using theorem by Hercules. Okay, because this one is a 90 degrees. So we can using 5 square plus 12 square. Then we go to square root. Okay, so from here we can find the answer. There's a 13 meter. Okay, after that direction is where? from O straight forward, go to the B. So that one we call it as a displacement. Yeah, remember this one method. So if you want to find the displacement, so there's a triangle in the perpendicular triangle. So that means you can using the theorem by Pythagoras. Okay, then we go to the next. Next is a speed. Okay, now you tell me how to find the speed. Okay, straightforward, give me the answer. And also the next one, sure, is a velocity. So the student, you ready? You straightforward do the calculation for the both question. Okay, you tell me speed is how many, then this velocity is how many. Okay, so we're going to see the student how to answer this question. Okay, we need to fast because later you still got class, is it? So that means we continue. Okay, anybody answer me? The speed. Okay, 1.13. Siliang give me the answer 1.13. So the others? Okay, Hong Yan also give me 1.13. Okay, now we go to check. Okay, now speed is a 17 meter per 15 second. Okay, meter per second. So that means your unit sure is a meter per second. So from here we go to check. Okay, 1.133 also can. Two decimal point is okay already. So there's a 1.13. Okay, after that you put meter per second. Okay, Wei Xuan correct. Okay, then we go to the next question. Okay, show me the answer for velocity. Okay, velocity. Okay, there's a same method, but velocity you need to remember. Just now the velocity we need using the displacement. Displacement means from the O go to the B. Okay, we're using 13 meter. Okay, we read the answer from the student. There's a stream live now. Okay, so from here, Hong Nian dash one, they give me the answer 0.86. Why got different one? Okay, Jaan, why you get negative one? Okay, where got negative? How come got negative? Okay, we get the answer from Chanel, 0.866. Okay, X7 also correct. So from here we show, okay, 13 meter per 15 second. Okay, so we go and check. The answer is 0.867 or you X7. Then after that we find it. There is a direction O to B. Okay, Jan type wrong, is it? Okay, so from here we're going to see the Debika also correct as 0.87. So you help me to mention where they go. Direction is from the O go to the B. Okay, because velocity is a vector quantities. Okay, so we go to the number 3. After landing on the runway, a plane they slow down. Slow down is a keyword. Slow down, that means later your acceleration sure got negative one. Okay, that's a velocity decreases from the 75 to 5 in 20 seconds. So what is the acceleration of the plane? Okay, now we go and write the info first. Okay, initial velocity is a 75. Okay, final they become 5. Okay, the time taken is a 20 second. So please find for me what is your acceleration. Okay, answer from the student. Okay, what is the deceleration? Okay, any question? Okay, we're waiting for the student. Okay, negative already. The student already showed me 4 students. Jia En, Si Liang. Jia En repeat. Jia En using the unit must be correct. Tan Chen Lu. Okay, we're going to pin the answer from the Tan Chen Lu. Okay, Chen Ru, they show me the answer is a negative 3.5. Okay, MS negative 2. So the unit must be correct. Okay, now we go and check. Okay, formula A equal V minus U over the T. So from here we take 5 minus 75 lah. Then unit is a meter. Sorry, it's a meter per second. Meter per second. So after that, I got 20 seconds. So final answer, okay, negative 3.5 ms, negative 2. Peter Yap, I think you put wrong already. Not meter per second. It's a meter per second second. Deepika also wrong. Dylan also wrong. Okay. Celian got asked, teacher, will the question ask you to find deceleration instead of acceleration? Yes. If the question mentioned deceleration, that means you no need to put negative. Understood? So if I change the question become what is the deceleration? Okay, we see that question from the Xiliang. Okay, if the question now the changes become deceleration. So your answer, you still show the calculation. You cannot disappear your negative, is it? Okay, you still show negative 3.5. Then final, you need to add one sentence. Deceleration is 3.5 ms negative 2. Okay, Xiliang? Okay, this question they ask about acceleration. So we straightforward until here, then we stop already. Okay, so this one is the question. Deceleration means already got negative. So we no need to write the answer negative already. Okay, so hopefully Celia answer your question. Okay, so from here we need to go to another one. Okay, ticker timer. So ticker timer is one of the vibrating object that can measure the motion of the object by using ticker tape. Okay, you can see this one is one of the carbon. Carbon is put below one of the nail. Okay, the nail will be vibrate. Okay, this one is a one of the white paper tape. We call it as a ticker tape. Okay, this one ticker tape when starting there's an empty lah, nothing. Okay, when I just put below the carbon, then this one vibrating plate later they will vibrate, is it? When it just vibrate, that means they will hit the carbon. After hit the carbon, they will hit the paper. Okay, when I hit the paper, that means you get dot 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 like Z. So if I never pull the ticker tape, that means this one vibrating blade, they just always hit at the same point. So now I go to pull. I pull the ticker tape. Okay, so when I just pull, that means the carbon dot that will appear for every part of the ticker tape. Agree, yeah? So if I pull faster, so what you think about the dot? The dot must go further. If I pull slowly, that means the dot is closer. Agree, yeah? So that means now we need to analyzing the motion by using the tape. Okay, by using the tape. Okay, now we're going to see the ticker timer. What's the function? They want to investigate the motion of the moving object. This one you can pull. You also can attach to one of the trolley. Then the trolley, you just let it to go down, fall down. Okay, when it just fall down, that means they can pull the ticker tape together. Then you can see the motion of the trolley. Okay, now we need to understand this one ticker timer, what characteristic. Okay, they're using 12 volt alternating current. Okay, alternating current means they can positive go negative, negative go to positive. That means when you join the wire, you want join reverse also can. You want to join correct also can. They never care about positive and negative terminal. Okay, reverse also can because they're using alternating current. Okay, alternating current means another thing we can make the plate continue to vibrate. If you're using direct current, that means they cannot vibrate. They just move one time only. So this one why we need to choose the alternating current. Let the vibrating plate continue to vibrate. Okay, one ticks. Okay, you see the word one ticks. The definition is a time interval between two dots. Okay, I'll show you what means of one ticks. Okay, this one is the ticker timer, the ticker tape. Okay, the dot, dot, dot later will come out, is it? So this one we call dot, two dots. The tick means center, the space we call tick. Okay, this one tick is a time taken to move between two dots. So tick is a time. Okay, not the space. So remember when I say one tick, then you must understood one tick means the time taken between two dots. We call one ticks. Okay, now the time taken to make 50 ticks. Okay, on the ticker tape is a 1 second. Means 1 second, the vibration can make 50 ticks. 50 ticks actually got how many dots? Okay, anybody can answer me? 50 ticks. Okay, ticks the space 50 ticks actually got how many dots? Okay, we go and simple only. You see this one ticker tape Okay, now is how many dot? One, two, three, four, five. Five dot is it? Okay, inside got how many ticks? One, two, three, four. Okay, five dots, four ticks. Okay, now I say I want 50 ticks. Chanel, no 100. Why become 100? 50 ticks. 50 ticks. How many dots? Not 100. 100 over already. Okay, you can see this one is five ticks. Five dots. One, two, three, four, five. Five dots. How many ticks? Four ticks. So that means the ticks is always less one. Okay, less one dots. Okay, 50 ticks. 50 ticks. Yeah, correct. Yong Chao Chin. Okay, the answer is 51. Farah, no 40. 50 ticks. That means your dot sure 51. Because every time the tick is less one from the dots. Wei Xuan, not 99. The answer is 51. 51 dots. Okay. So from here, we need to know this one vibration 50 ticks, then using 1 second. 1 second can move 50 ticks already. That means 51 dots. Okay, now I need to count. One ticks, the time taken is how long? Okay, one ticks. Okay, so from here I need to show the calculation. Okay, one ticks means 1 over 50. Okay, 1 over 50, 1 second over 50 ticks. Okay, 1 over 50 ticks, then I get it 0.02 second. Means you want to make dot to dot, one tick, the time taken is 0.02 second. Okay, very fast already, is it? So another things, 5 ticks means 0.1 second. You take the 5 multiplies 0.02. Okay, if I say now it's a 10 ticks. 10 ticks, the time taken is how long? Okay, anybody can answer me? 10 ticks. Okay, if I make 10 ticks, 10 ticks means got 11 dot. Okay, got how many seconds? Okay, if 10 ticks, that means you just take the 10. Peter, why suddenly got E? Okay, 10 ticks. 0.2 second. Yeah, correct. Silang correct. So we go through here. 10 ticks means 0.2 second. So you remember one tick is how long first? Okay, one tick is a 0.02 second. Okay, so we continue. Chanel, no 10 second. Okay, Peter, 2 second also wrong. There's 0.2. Okay, now we go to ticker tape. Okay, this one is a ticker tape. Okay, here got how many dots? We got 1, 2, 3, 4, 5, 6. We got 6 dots. Okay, this one is the direction of the motion. That means this one come out first. I pull the ticker tape to come out. So this one should be the starting. This one should be the ending lah. Okay, so from here, when I pull, can you see the dot is further and further? So further and further mean faster already lah. I pull very fast. So that means this one is the first, this one should be the last. Okay, here got how many ticks? Okay, we got 5 dot, only got 4 ticks. Agree, sorry, 4 ticks. Okay, 1, 2, 3, 4, 5 ticks. Okay, how many dot? 1, 2, 3, 4, 5, 6. 6 dot, 5 ticks. Okay, now this one is a displacement over the 5 ticks period. So the time taken is how long? 5 multiplied 0.02 second, so 0.1 second. So understood? Every space, the time taken is 0.02. No changes. Although this one further, the time taken still the same. Okay, because there's a vibrating from the plate. The plate every time vibrate is the same one. Why further? Because you pull faster. Different, eh? So distant further, because you pull faster. The time taken still constant, 0.02. Okay, now we go to explain. Velocity and also acceleration of the linear motion of the object can be calculated by using ticker tape. Okay, we can calculate velocity, we can calculate acceleration. Okay, now we go to calculate the velocity. Okay, first one, you can see here got how many dot? 1, 2, 3, 4, 5, 6, 7. 7 dot, 6 ticks. Okay, 6 ticks. Okay, from here, please calculate the displacement. Calculate the velocity. Okay, displacement already is a 18 cm. Time taken for the 6 ticks, 6 multiplies 0.02 second, so becomes 0.12 second. Okay, now I want you to show me what is the velocity. Okay, give me the answer of velocity. Okay, what's the answer for the velocity? Okay, anybody can answer me? Velocity. Okay, we just take, okay, 150 cm per second. Okay, from Xiliang. Okay, we're going to check the others. Okay, let's see here. So, S over T, displacement over time. Okay, Shani also correct. So, 15 cm over 0.12 seconds. So, the 150 cm per second. So, remember, this one cm, then we're using cm. Okay, correct. Gu Hongye also correct. Okay, then we go to the next. Okay, now we need to calculate is the acceleration. Okay, now we're going to see. Acceleration, that means you need to find out initial and final. Okay, this one's the direction of the pulling. So this one should be the starting, this one should be the ending. Okay, here got how many dots? Here got 8 dots. Okay, 8 dots, 7 ticks. Okay, now we're going to check. This one is a starting. Dot to dot means 1 ticks. 1 ticks is 1.2 cm. The final ticks is a 3.6 cm. Okay, the center you no need to see already because you need to find acceleration. Okay, so from here we write the info. Initial velocity. We need to find one by one because your acceleration is v minus u. You need to find initial, you need to find the final. So anybody can type for me. Initial velocity is how many? Okay, initial velocity for the first tick. I want the first tick. So show me the answer. Okay, I just want the velocity for the first tick. Okay, what's the answer for the first tick? Okay, anybody can answer me? 1.2. 1.2 is a cm, is it? 60. Okay, we're going to check. See which one answer should be correct. Okay, so we're going to show. Okay, correct. Correct. So that means the answer is you take 1.2 cm, that's a displacement over the time. The time is 0.02 second because just now I show you already. Okay, the ticks always is a 0.02 second. So we get 60 cm per second. Okay, then we go to the second one. Second one is a final. Okay, we need to find out final velocity is how many. That means the last one, the 7 ticks. Okay, the 7 ticks. What is the velocity? Okay, we're going to check for the student. Okay, any student can answer. Okay, we're going to find out the student can answer now. Okay, Jian again, 100. Okay, we're going to check. From here, okay, 180 cm per second. So we take 3.6 over 0.02. Okay, so this one just simple. Now, not our answer. This one just the sum of the part only. So we continue with the question. Okay, we find the starting 60. Then the final is a 180. So that means this one already is an acceleration. Okay, now the problem, we need to find the time. Okay, remember formula A equal V minus U over T, is it? Okay, so time between the final and initial. Between, from the final to the initial. Okay, how we go to find the time? We cannot say the time is a 7 multiplied 0.02. No, that's not the answer. Okay, I want between. Between, that means you need to minus 1. Okay, minus 1. Example, from the 1 you go 2, become 1. 2 to 3 is a 2. 3 to 4 is a 3. 4 to 5 is a 4. 5 to 6 is a 5. Then 6 to 7 is a 6. That means when I ask about between, you need to minus 1. Okay, so from here we show, okay, correct. Wen Xuan, you are correct. Okay, the time taken is 0.12. Okay, Wen Xuan, once you go to delete your answer, that's a correct. 7 minus 1. Okay, if you want to find the time between final and the first, we need to minus 1 ticks. Okay, we need to minus 1 ticks. So from here, 7 minus 1 ticks, so that got 6 only. 6 multiplies 0.02 second, so it becomes 0.12 second. Okay, this one is a special for acceleration. Velocity, you no need to minus. Just acceleration, the time, you need to minus. So this one time, we call it as an ellipse time. Okay, now we can do the calculation for acceleration. So that means acceleration is a V minus U over T. So from here, we need to show 180 minus 60. Then over the time taken. Okay, so from here, the answer is 1000 cms negative 2. Okay, so this one is the answer for the acceleration when you find from the ticker tape. Okay, now is an example 1. Okay, I think our time until 45, is it? So faster, we go and do this question. Calculate the velocity of the motion object. So the velocity is a 10 tick, is it? 10 tick, understood. The time taken is a, okay, Jian, correct. Your answer 1000. Okay, we show. Okay, time taken is a 10 ticks multiplied 0.02, so 0.2 second. So displacement is 20 cm. So I straightforward to show the answer. So there's a 20 over 0.2, there's 100 cms negative 1. Okay, I think this one no problem for you all. Okay, example 2. Okay, example 2, can you see they become bar and bar? Okay, so from here, okay, Kumar got answer. Tickle, can teacher explain the ticker tape again? I'm confused. Kumar, you can PM me if you're in my class. Okay, because now I want to continue for the lesson because we're until 9:45 only. So that means you want to know about more about the ticker tape, how to count. Then you can ask me. Okay, this is simple only. Just a dot dot dot. Then the dot and dot center we call tick. Then the time taken dot between the dot, that's a 0.02 second. Just a simple only. Okay, we continue for this part. Calculate acceleration of the motion. So you can see the arrow. The arrow starting from here means this one is the initial, this one should be the final. Okay, how we go to do calculation? Okay, 1 bar is a 10 ticks. So that means time for 1 bar is a 10 multiplied 0.02 means 0.2 second. So 1 bar, 0.2 second. Okay, now we need to find initial. Initial, that means 5 cm. 5 cm over 0.2, so 25 cm per second. Okay, next one, the final, 12 cm per 0.2. So we get the answer is a 60 cms negative 1. Okay, now we need to find the time. Okay, let's see the timer. Okay, time we need to count bar by bar. So you can see here got how many bar? 1, 2, 3, 4, 5. 5 bar. Okay, remember I told you the time taken you need to minus 1, is it? So just now is ticks to ticks. Now is bar to bar. So that means time between the final and initial velocity. So that means we need to minus. You take 5 bar minus 1. Okay, just now is a tick, is it? You take how many ticks? You minus 1 tick, is it? Now I don't want count by ticks. I want to count by bar. Okay, 1 bar inside got 1 ticks. So you just assume lah, this one is a 1 tick, second tick, third, fourth, 5. Okay, so we got 5 bar here. You minus 1 bar because you want to find between. So we got 4 bar only lor. Then 4 multiply 1 bar. The time taken is how long? 0.2. So 4 multiply 0.2 then becomes 0.8 second. Okay, now we need to do the calculation. Okay, calculation V minus U over T. So the V is how many? 60, is it? 60 minus 25. Then over the time taken. Okay, the time taken just now is 0.8 second. So we get it, the answer is a 43.75 cms negative 2. Okay, for the time taken, you must be very careful because this one is for the acceleration only. Velocity, we no need care about that. Okay, so from here, you can repeat to see what I mentioned just now lah for this video. Okay, so from here we can say a long ticker tape can be divided into strip with an equal number of the ticks. Okay, this one strip can be cut. Okay, wait, I answer one of the question from the student first because now I got class. Uh, uh, then okay, I will answer student. Then we'll start. Okay, so from here, this one strip they can cut. Okay, because long ticker tape, is it? So we need to divide. So just now I show you the bar, is it? So that means now I want to divide, then I paste side to side. So from here, we show here. Okay, this one is a long ticker tape. Okay, when I cut, I count how many dots, 1, 2, 3, 4, 5. So every 5 dot I go to cut. Then I go to paste side to side. So you can see here, every tape is the same length, is it? So this one we call it as a uniform velocity. Okay, you pull the ticker tape with uniform velocity. So when I just paste, you can see very clear already. Okay, every tape is the same length. Okay, another situation like this. When starting, I pull slow. Then I pull faster. So I go to cut. So when starting 5 ticks, another 5 ticks, and last 5 ticks. So you can see they keep increasing, is it? Okay, then you need to measure using your meter rule to measure what is the length. So when I find it, every length is a different 1 cm. Maybe this one 2, 3, 4, 5, 6 cm. So that means we call it uniform acceleration. Okay, because they keep increasing. Okay, and the last one, if I pull like this, okay, I faster, then become slow down. So I cut one by one, I go to pace. So you find it when starting 6 cm, then 5, 4, 3, 2. So this one we call velocity decreasing uniformly. Or you can say uniform deceleration. Okay, so from here we just see the ticker tape, then we know the answer already. Okay, understood the motion. So from here, we can see about the motion. We can know about the acceleration for the object, how to move. Okay, we just analyzing the ticker tape. Okay, so here got some of the extra explanation you can see here. Okay, ticker tape and also the chart. Okay, first one, when you see the dot is constant. So this one, what's the meaning? Okay, this one arrow means you go to pull. So this one called uniform velocity. Okay, so another one, this one also uniform velocity, but this one I pull faster a little bit. Can you see the dot and dot further? So this one we call it uniform velocity, also same, but now I pull faster a little bit. So you can find it further. When I cut it, become paste side to side, they become like this. Okay, so this one called uniform velocity. Okay, the next one. Okay, like this. I pull faster. Okay, closer, after that further, is it? Then I paste. Okay, after paste, I go to measure the length. So 0 0.5, 1.2, 1.9, 2.6. Everyone different 0 0.7. Okay, constant 0 0.7 already. So we can say distance between the dots increasing uniformly. Okay, everyone increasing uniformly. So we can conclude velocity increase uniformly. Okay, distance increase uniformly means the velocity now increase uniformly. So we can say the object moving uniform acceleration. So the object now got pick up, got faster. Because from the 0 0.5, they're faster until 4. So every difference is 0 0.7. So they got increasing 0 0.7. So we can say there's an accelerate. Okay. So this one is a motion graph. Okay. Okay, another motion graph is come down. That means slow down. When starting, I pull faster, then becomes slow. So this one is a arrangement when I put the ticker tape side to side. So this one distance between the dot is decreasing uniformly. Uniformly, not uniformly, you need to measure lah. Okay, maybe this one is a 5, 4, 3, 2, 1. So everyone different is a 1 cm. So we can say uniformly. Okay, velocity decreasing uniformly. Then the object experiences uniform deceleration. Okay, so this one is same like just now what I explained for you. Okay, here got some of the extra notes for you to understand the question. Okay, if the question say uniform means constant means same. Okay, increasing velocity means acceleration. Okay, if I say decreasing velocity means slow down, or you can say deceleration. Okay, zero velocity, what's the meaning? The object is stationary. That means the object is a rest. Okay, negative velocity. Negative velocity means the object move in opposite direction. So you must be careful. When I mention negative velocity means the object in opposite direction. Uniform velocity means zero acceleration. That means your velocity always 20, 20, 20. That means there's a flat. Flat means what? Zero acceleration. Okay, last one, negative acceleration. Okay, negative acceleration means deceleration. Or you say retardation. Okay, they move in opposite direction of the acceleration. Okay, so this one is an extra notes for you to understand the question. Okay, so today we just until here only. Okay, so next lesson I will go through this part. Okay, from your textbook you can find out. Okay, using the linear motion equation. Okay, so this one is my channel for the YouTube. Okay, one thing to tell the student, you need to go to answer the question in the Google Classroom. I already upload some of the exercise you need to print out. Okay, after that you need to answer the Google form as today attendance. So inside got one of the question. Okay, that question is today code. Okay, I'm going to find out the code first. Okay, code. Lim Si Liang, you help me to type the code. Okay, hashtag, you put hashtag, then distance, DISTANCE, capital letter, no space. Okay, hashtag, distance, then after that, 2021. Okay, help me to type here. Okay, Celia, help me to type here to show the student. Hashtag, distance. Okay, I try to type here. See can type or not. Okay. Okay, hashtag 2021. You help me to add Celia. 2021. Okay, I go to type here. Hashtag, you put hashtag. Where's my hashtag? Okay, hashtag. Then you put capital letter distance. Okay, then you put 2021. Okay, then I go to chat. Okay, you can see here in Google Classroom. Yeah, Google Classroom inside got Google Form. Okay, correct. Distance, TISDANTANCE 2021 hashtag in front. So no space. If you space, that means wrong already. No space. Okay. So today our lesson just until here lah for the student. Okay, so our lesson last ready. So just until this part. Okay, so thank you for your attendance today. So hopefully you can download the exercise, then you can do it. Okay, thank you for the student. Okay. Bye, Tipika Mohan. Bye. So please go to type your attendance. Okay, bye everyone. Bye. Okay, thank you, Dylan.